Experimental studies of the microstructure of localized shear bands carried out in a number of studies show that one of the mechanisms for the formation of plastic shear bands is multiple instabilities in the meso-level defect system. The purpose of this work is to provide theoretical framework and experimental supporting evidence for a crucial role of structural transitions in the ensemble of defects at the meso-level, microshears and microcracks, as one of the mechanisms of plastic strain localization in metals under high-rate loading. The mechanisms of plastic strain localization in the material subjected to dynamic loading were studied in a split Hopkinson pressure bar using the specimens made of aluminum alloy AMg6, which exhibits the plastic flow instability. The skewed specimens were used to initiate the plastic strain localization at sufficiently high strain rate. The dissipation-driven temperature fields observed in the specimens subjected to deformation in the Hopkinson pressure bar setup were investigated by CEDIP Silver 450M high-speed infrared camera, Figure 1. During deformation, the temperature fields were visualized in situ. The temperature of the plastic strain localization does not exceed 150. This has led to the conclusion that thermal softening does not play a decisive role in the localized shear mechanism under these loading conditions. The results of structural analysis of the specimens after testing on the split Hopkinson pressure bar are shown in Figure 2. The structural volumes, grains, in which the conditions for plastic deformation were realized, became the sites of formation of structural elements with characteristic features of localized shear bands. Figure 2. The comparison of the experimentally obtained values of temperature and deformation fields with the results of numerical simulation performed to take into account specific features of the kinetics of microshears accumulation in the material showed satisfactory agreement with accuracy of approximately 20%. The results of theoretical and experimental studies suggest that one of the mechanisms of plastic strain localization in the examined material and for realized loading conditions is predominantly associated with the evolutionary processes in the defect subsystems under the conditions of correlated behavior of defect structures.